Let's talk about the fundamental theorem of calculus. I'm talking about one part, there's actually two parts. Look at some of the notation. We talked about this in the last video, that the integral of f prime dx is really the summation of delta f over delta x times dx when delta x goes to 0. Where these two will cancel out because dx means delta x goes to 0. So this integral from x equals a to x equals b, what that really gives me of f prime is the total change, the sum of all my tiny delta f's, which gives me the total change in f of x. In other words, if I want to find the integral from x equals a to x equals b, this part is implied, you're going to need to know that, of f prime dx, it's the change in f. What's the change in f? It's the function value at the end minus the function value at the start. So if I want to find the area between this curve, or really between this curve and the x-axis, starting at x equals 0 and ending at x equals 1, what I can do is I can find the antiderivative We're going to see that we don't really need that plus c, but I'll put it there for the first example. And I'm going to evaluate it from x equals 0 to x equals 1. So this is my derivative, if you would. This is my function f of x. How do I evaluate this? I find the function value at its endpoint, x equals 1. Given that this would be like f prime, minus the function value at the start point, at 0. The total change in f. Here's why we don't need the plus c if I'm doing what's called a definite integral. An integral where I definitely know where I start and where I end. Why do I not need the plus c? Because it will always cancel out if I do it correctly. So I end up with 4 minus 0. So the area between the curves, or beneath the curve, from x equals 0 to 1 of this function is exactly 4. Let's do another example over here. Let me draw a picture for this one because I know what this one looks like. So what I'm really asking for is what is the area beneath this curve on the interval natural log of 4 to x equals 2? Well, how do I find that? I can do the antiderivative of this function, which happens to be itself, from natural log of 4 to x equals 2, but what I need to do is find the change, so I'm going to plug in the end value, my end x, minus plug in my start value, the change in f. And I will simplify a little bit just because e to the natural log of 4 equals 4. So my claim is that this area right here is equal to e squared minus 4. Pause if you need to copy this picture down. Notice that I have a graph of g prime of x. I'm telling you g of 0 equals 2. G prime of 0 equals 2, that's just a coincidence. G of 0 equals 2, I don't know what the graph looks like of g. I don't have a graph of g, just g prime. But I'm asking to find values of g. Well, how could I do this? I can use a fundamental theorem of calculus. I know that the integral from 0 to 4 of g prime of x equals g of 4 minus g of 0. So I'm fine with this first one over here. So how did I know to use x equals 0 and x equals 4? Simply, I know the value of g at x equals 0. I'm trying to find the value of g at x equals 4. So from x equals 0 to 4, it makes sense that I would use those values. Fundamental theorem of calculus says this is true. So if I know this, and if I know this, which I obviously do, then I can find what I'm looking for. I could say g of 4 is g of 0 plus the integral from 0 to 4 of g prime of x dx. Well, I know this is 2. My claim is that I know this also. Well, how can I find the integral from 0 to 4 g prime of x if I don't know what g prime is? Well, I guess I could figure out the equation, I could do an antiderivative, but I could do something even simpler, is recall that the integral, sure, is the antiderivative, but it's also the area beneath the curve. So I'm going to take the easy route here and find the area beneath the curve on 0 to 4. Since I have a triangle whose area is 1/2 base times height, I find that that area is 4. Which gives me that g of 4 equals 6. What if I want to find g of -2? I could certainly do a similar thing. The only thing I don't know in this equation up here is what I'm trying to find. So I'm going to plug in the values first. I have the integral from -2 to 0. I'll use the area again. I got a triangle whose area is 2 this time. So I have 2 equals g of 0, which I'm doing a lot of 2's here. 2 minus g of -2. Notice if I solve this out, I'm just going to do it in my head though. I get g of -2 must equal 0.